Okay, so here we go. Alright, so we're going to go ahead and log into our remote desktop. And it's going to ask me for a magical password. And we're going to go ahead and check that. And voila. Cool. There it goes. Wait for it to load full resolution. Alright, so. Okay, so we need to go in here and we need to go ahead and launch our updates. Some things can be managed by your organization. Well, we haven't done any of that yet, so that's not a big deal. Okay, we need to get all these updates done before we do too much. So, alright, so we'll get those updates done. Let's see. Other thing we need to do is we need to go in here and we need to set up Hyper-V. So we need to go into manage, add roles, skip this stupid thing. Now you can do virtual desktop infrastructure. The issue with that is the licensing. So it's actually easier just to do everything through Hyper-V. It's kind of an old-fashioned way of doing it, but also tends to not have as many little quirky, weird issues sometimes. So we'll just do it this way. Okay, select server. Oh, server pool. Hyper-V, and I always like to make sure we add everything, because last thing you want to do is not add something and then it not want to work right. So add all the subcomponents. We got plenty of storage space, so we're not limited there. Let's see, we don't need a backup server, we don't need migration tools or any of that. So, okay, next. All right. Virtual switches. That's fine for now. Because I can actually change that later. Actually, we don't need that and we can always change it later. And it's just simply because of the fact that we don't need the live migrations because we're only doing one site. Live migrations is kind of a good thing is if you're running an enterprise and you have multiple locations and you want to be able to relocate virtual machines on the fly over the internet and relocate them from one server to another server. That comes in handy, but in this particular, this site is not going to be at that scale, so we don't have to worry about it. Okay. All right, and install. Okay, so while that is doing that, we're going to go into disk management, and we are going to set up our other disks. So, and all right, so we're going to cancel that for now because we're going to do some fancy stuff. So, anyways, all right, so we're going to resize this guy so we can actually see what the heck we're doing. Okay, so, all right, so one thing we need to do is we need to convert this disk to dynamic. Okay. And then we need to initialize this guy. And we can just initialize them MBR for now. And okay. Because we're going to convert them all to dynamic anyways. So we're going to convert all of them to dynamic. Okay, so they're all converted to dynamic. Now we need to go through and we need to add a mirror for our system drive. Switch. Actually, I want to relabel this OS. Okay. All right. Nope. Right click here, add mirror, and our mirror is going to be disk 5. Different partition style. Oh, it's GPT table. That would be why. Okay, so we're gonna have to set this to GPT, which means we'll have to set our 0 through 3 up the same way. Okay, now we can add a mirror, because our partition tabling system has to be the same. Otherwise it won't work, right? Alright, so add mirror. And voila. Okay, so what happens here is Windows now automatically manages these two drives as a pair. So whatever happens on our OS drive here automatically happens on our mirrored drive down here. So every time you reboot, these two drives have to go through and resync. That can take a fair amount of time because it's a background process within the Windows subsystem. So yeah. Anyways, okay, so that's going on. All right. And of course, we don't have a lot on those drives right now. So right now we've only got OSC and it's 98% free. So we've only got about 22 gigs that we're actually using. So it's got to resync the 22 gigs between these two drives. The one nice thing is they're NVMe SSD, so it won't take very long. All right, so with this guy, now, so we need to convert these guys to GPT. All right, so then we're going to add a RAID 5 volume. Now this is only available in server. You can't do this in Windows 10 Pro. I'd love it if you could, but it is a server function. So we're going to add a RAID 5, and then we're going to add our other disks over. Hit next, and this is going to be our, oh, we'll have to change that later. That's fine. All right, and this is just going to be our data drive. And voila, everything's teal. Okay. So that's our drive setup right there. Okay. And then these have to resync too. Of course, there's no data on them, so the resyncing won't take very long. So, all right. So that's it for all that. And, ooh, we cracked 5%. Oh my God. and we're running right around 2.5%. Like I said, I believe the max boost on this chip is 2.8. So this will bounce around. But okay. We still haven't even cracked 5 gigs of usage yet on the memory. So, okay. All right. So there is that. Okay. So that's it. So that's the basic setup. We're going to wait for Hyper-V to finish installing here. And then once that finishes installing, then we'll go ahead and we'll reboot and we will set up our other Hyper-Vs, our other operating systems. So we'll have another server installation because that will be our Active Directory domain controller, and then we'll set up a few Windows 10 machines, and I'll show you some cool tricks on how to do that. So, all right, so that's it for now. Okay, so our Hyper-V is almost done installing here. So in the meantime, while that's doing its thing, we're going to go ahead and we're going to create a couple of things. So we're going to create a folder for our ISOs. Okay, and then we're going to take, that's that. We want this one. Okay, there we go. So this is the MS Win Server 2019 Standard Edition DB ISO. So we're just going to copy this over here. So that's going to cook fairly quick. Restart is pending. Okay, so it's waiting for me to finish copying this file. All right. Click the right one, smarte pants. Okay, there it is. All right, so there's our ISO file for that. So we're going to need that for later. All right, so now, okay, so we can go ahead and reboot. Oh, and we need to update too. So we're going to go ahead and make sure pending restart. Okay, cool. All right, we're going to restart now. And we'll be back in a moment. Okay, we are back. So, as you can tell, we've totally finished all of our updates. We're completely up to date now. So we can get rid of this. We've already gone ahead and activated Windows. So we're good there. Our Hyper-V is totally installed. Our RAID 5 is still in the process of resynchronizing, which is fine. It'll take a while for it to do that, just because they're mechanical drives and they just take time. But you can see our OS mirror down here is totally healthy and fully finished resyncing. So now we can go ahead and start installing some software. So there's a couple things we're going to do. But first, I want to go ahead and get the Hyper-V started. So, all right. So we're going to open up, from our server manager, which opens the first thing when you launch everything. So this is what you'll see when Windows first starts on server. So we'll go to our Hyper-V, we're going to right click here, go to Hyper-V Manager, and that brings up our manager. And we're going to blow this up, make it a little bigger. Okay, so this is our server, this is the manager. So you can actually manage multiple Hyper-V servers from one console. You just have to go here, connect a server and another computer or a local computer, and then you can connect up and away you go. So, but we don't need that. So, all right. So from here, so we're going to go ahead and create a new virtual machine. So we can hit new over here. We're going to hit virtual machine. And we're going to get rid of this so it doesn't show that every single time we do this, because we're going to do this a few times. So, okay, so new virtual machine. So this was going to be our Active Directory controller. So this will be, let's see, AD controller. Okay. And I actually like to change this, and for easy access for everything, I like to change it so it's actually in the root directory. So that way I'm not having to dig all the way through a whole bunch of Windows directories just to get to what I want. So okay. All right, there we go. We'll keep everything in there. And we're going to do Gen 2. Gen 2 gives you added support. Gen 1 would be like, for whatever reason, if you needed to install, say you needed to do a Windows XP virtual machine on here because you had some old legacy software that only ran on XP or something, and that's what you would use that for. Gen 2 supports UEFI-based operating systems for added security, plus it only runs 64-bit OS. It will not run 32-bit at all. So anything Windows-based anymore, you're going to run 64-bit. I don't know of any current reasons why you would run 32-bit unless you're running Windows on say a tablet or something that didn't have a lot of memory for whatever reason. So all right, so we'll hit next there, start up memory. So let's see, so we're doing a server, and this is going to be our AD server. So we're going to do 1024 times 16. All right, we're going to paste that in there. And for a server, I like to go ahead and just lock it, so that way it automatically allocates that much memory for the system. So that way your memory usage isn't going to fluctuate back and forth all the time. All right, so then let's see, we got that. We can actually leave that not connected for right now, because I keep forgetting to do something. I need to go back and do it, but that's okay. Let's see, so 80 controller, PhD, and we're storing it in Hyper-V, and there we go. Okay. All right, so we're going to go ahead and we're going to set it up with 250 gigs. It's not going to pre-allocate that much memory, so most time it will create it in chunks. So all right, and then we're going to install from our ISO file, which we already have. When we do the XP Pro installations, I'll actually show you a trick to not having to have an ISO necessarily. So, which kind of comes in handy. All right, so we created an ISO folder on our data RAID 5 set, and there's that guy. So we'll go back here, and we're all ready to go. So we're gonna hit finish, it's going to go ahead and create the drives real quick. And because it's SSD and it's a 16 core system, it's going to do it really quick. So, all right, awesome. Now, the one thing I keep forgetting to do, we need to go into here, and we need to change a couple of things. So, all right, so we need to change these guys. So, we're going to call this controller interface, and we're going to call this one our virtual machine interface, which is currently disconnected, but that's okay. So, all right. Because what we want to do is everybody's going to be on the virtual machine interface is where we're going to have all of our Windows 10 virtual machines, and everybody's going to be logging in on those. But those we want on a separate network card or network interface, so that way we're not bogging down one interface all the time. Also takes strain off the switch as well. So then everything will go over here, and this is where it'll access files and everything, and we off the controller interface. So just to kind of build in some load balancing in there without having to go through and set it up. Set up load balancing in Windows and then set up load balancing within the switch and everything else. This just makes it a little bit easier. So, okay, so that takes care of that. All right, so now we can go in here, we can go to settings, and we can go to network, and we can actually that's the virtual switch. Oh, okay. I always forget about that. Okay, so let's see. We actually need to go to virtual switch settings, and we actually need to add external network number 2. All right, so that is our controller. Okay. So we're going to rename this virtual switch controller switch. Okay. All right. Now the difference between an external network is it actually will pull IP addresses. If you're running a DHCP server, it'll pull IP addresses from the actual network it's physically connected to. If you do internal network, that's an internal virtual switch within the within the Hyper-V. So by default, it will come up with like a 172 net or something like that. So, which is fine in certain instances. If you wanted to take and say you were trying to segment off your server, so say you were leasing time to other companies for your server within certain virtual machines within your own server, then that would come in handy, because then you can segment and sub-isolate everybody out. But yeah, in this particular instance, this is a small business. external works perfectly fine for that. So, all right. So we're going to apply this, and we're not going to add any notes right now because we don't really need to. All right, so we're going to go ahead and turn this guy on. Okay. And well, because we loaded the ISO file, it thinks we're just booting off a CD-ROM drive. So it's going to go ahead and it's going to load Windows. Now, of course, this is actually going really quick, and the reason it's going really quick is because we're running this off of the SSD, the NVMe SSDs in the system. So this will actually go pretty fast. We're not going to load the product key right now. Right here, like this. Oh, the other thing we need to change is we need to go ahead and change our, there's our drive. So installing Windows within a virtual machine is no different than installing Windows inside of anything else on a physical machine. So you're just using a little virtual terminal to be able to see anything. So, okay. So now we need to go in here and we need to go to new virtual machine. Actually, no, we're not going to do that just yet. So we need to do our, what I call my dirty little Windows virtual machine trick. And it's not really a dirty trick, it's just another way to skin the cat, basically. So we're going to go in here, we're going to go new, and we're going to go create a separate virtual disk. Okay. And up to, all right, yeah, we don't want to set, we're just going to do a VHXD because that's the default. Now VHXD supports dynamically expanding. This one's just going to be a fixed size because what we're doing is we're going to copy a data set. So, and this is our Win 10 installer drive. Okay, so we're going to go here and we are going to go back to our data, go to our ISO. And we're just going to put it inside of our ISO because our ISOs are basically going to be our installer data anyways. So, alright, so then we want to copy a physical drive. Oh, that's rebooting, so that's almost done. Awesome. Oh, okay. I'm misreading it. Ha ha. I'm a dork. Okay, so this is 20. I'm expecting this to say 64 because it's a 64 gig drive, but it's split when Windows created the drive. So, okay. So we're going to copy our drive 6, which is our bootable Windows 10 flash drive, and hit finish. Failed to convert the virtual disk, failed to convert. Really? Well, that's interesting. Alright, so we're just going to cancel that. Alright, so we're just going to use my magic default password for everything. Well, not everything. Certain things. Okay, so there we go. So our other instance of server is already set up and installed. And this will be our AD controller. Fun fact, you don't get to see that part because that's going to be specialty client information. So sorry, no fun for you, but that's okay. So we're actually going to go ahead and we are going to shut it down for now because we need to change a couple of things. Alright, so we're going to take this guy and we're going to go to our settings and we're going to go to our processor and we're going to put 8 threads on this thing. So, and we're not running a super robust system. We're not trying to run like 100 virtual instances on a single machine or something like that. So I always do the reserve at 0 and the limit of total resources at 100. I just leave this all at default. If you had, say, 50 or 100 different instances on a single machine, then you would have to go in and you would have to set weighted percentages for total system usage, and so that way the Hyper-V can prioritize certain machines with certain amounts of resources automatically, and that way they don't one virtual machine is not trying to utilize and overtake all the resources of the entire physical system all the time. So you have to, that's what this is for, is to go through and kind of load balance everything out. You can also do the same thing. We're going to apply that, and with the memory you can set it up for dynamic memory, which we haven't done in this because I usually don't do it in a server situation. In a desktop, in a virtual desktop situation, then yes, I will. I'll set it up for a dynamic because the one nice thing with dynamic is you can run more instances than what you physically have memory available for, because not every instance is going to run. Say if you authorize it for 8 gigs of RAM, it's not going to utilize all those 8 gigs all the time. So instead of pre-allocating all 8 gigs all the time, you're only pre-allocating what the system actually needs at the time. So you're setting a maximum limit versus setting the whole thing for that amount all the time. So just kind of one of those things. And then memory weight, this is again prioritization of this virtual machine versus all the other virtual machines. So alright, so there's all that. Okay, and then network adapter. Oh, okay, so we need to set this to the controller switch. Apply that. And because we changed that after we created it. And okay, that's it. And actually we can go ahead and we can disconnect that, so that way we're not keeping that in use all the time and it's not constantly accessing that drive all the time. So okay, so there we go. Alright, so actually we can go ahead and restart this. And of course the main reason I did that was because of the fact that was just to load it or the main reason I shut it down was because changing memory settings, changing So changing memory settings and changing processor thread counts has to be done when the machine is stopped. You cannot change that while the machine is running. So, and certain things will require the virtual machine actually be rebooted. So, easy enough just to do it now while we're doing this. So, okay. So there we go. Of course, we go to the task manager in here, in our virtual machine, go to performance, and you can see it says we have a 16 core. We have one virtual socket with 18 cores on it, or 18 threads. Because in a virtual machine, there is no virtual, it doesn't count sockets versus threads. It just counts basically threads. So there's our memory, 16 gigs. If this was dynamic, this would be whatever is actually been pre-allocated for the machine. And then this would dynamically change all the time. So, okay. All right, and then there's our Hyper-V Ethernet. So, okay, that's good. All right, so we can actually close this. We don't need that open right now. All right, so now, okay, so we're gonna do another virtual machine. We're going to do a Win 10 Pro. Okay, yep. So we're going to do a Win 10 Pro, and we're going to put it in our store that is outside of all this stuff. Okay. Next, and we're going to do Gen 2 again, and we're actually going to do, because Windows really requires, Windows 10 anyways, really requires 8 gigs of RAM to run properly all the time. Hopefully you have your number lock on. 10, 24, 8. We're going to do 8 gigs, and we're going to use dynamic memory. So basically what this does is this sets the maximum limit that the virtual machine can allocate. So we have 64 gigs of RAM on this server, which is more than enough for what we're doing. So I'm going to hit next. And I didn't go through and create another switch, did I? Alright, I'll have to do that. Alright, so we can leave that for now. Next. Alright, so there's our drive, and it's 127 gigs, which is the minimum baseline, which is perfectly fine. We can leave it like that. And we're going to install the operating system later. Finish. Create the drive real quick, and we're done. Alright, so there's that. Okay. So we need to go to Virtual Switch Manager and External, create Virtual Switch. So this is going to be our second switch. This is going to be our VM. Whoops. VM switch. All right. And that's going to be on this 10 gig interface. And we're going to hit apply. We need to start network connectivity. Yeah. All right, so there we go. Hit OK. All right, so there's that. Because I already had an existing virtual drive from a Hyper-V server anyways, so I copied that file over. So all I need to do is go in here now and add it. So now we're gonna go in here, we're gonna add a drive, and we're gonna hit browse, go in here, Win 10 setup, hit apply, and there we go. All right, so now we can go ahead and we can start this guy. And there we go. See, there's our boot manager. Okay, so we're gonna go ahead and turn this off real quick. Failed to stop. There we go. Okay, so we're gonna go ahead and change this. I'm gonna go settings, and we're gonna go processor, change this to 4. Because Windows 10 really needs 4 threads to run right. We're gonna go network adapter, and we're gonna add it to the VM switch, and hit apply. Okay, and there we go. So we got our 8 gigs of RAM, which is actually dynamic. So it actually starts with 512 megs. Yeah, good luck. And then, which we can actually change this. I'm just gonna go ahead and change this to, most of them so we're gonna make it 1024. So we're gonna give it a gig just to start. Actually, no, we'll do 2048. We'll give it 2 gigs. Oddly enough, the one machine I run was just the virtual machine, the Hyper-V virtual machine that I run just to run my QuickBooks, runs 2 gigs like all the time, because that's all it's running. It's running Windows, and it's running Quicken. That's it. That's all it does. So, okay, so we're gonna apply that, and we're good there. Okay, now we can go ahead and start this guy. And we'll be good to go. So we're just gonna install Windows here real quick. And we're gonna get this all nice and set up, and of course we're gonna do middle product key, and we're gonna do pro, and we're gonna accept, and custom, and okay, so this is our drive 1, so that's our installer drive. We're gonna install it on this one. And 127 gigs, honestly, for a VM machine is really more than enough, because you're not going to install a ton of programs on a VM. You're just going to install what you need to for whoever's utilizing that machine to work, to do their stuff. So, yeah, usually 120 plus gigs is perfectly fine. We just need enough room to run Windows, and that's it. And of course, we only have, we're running all the VMs off the SSD drives, and so we only have 1 terabyte of usable space. So we don't want to load up that drive all the way really, really quick. If we can get away with it. So, all right, so that's going ahead and installing. So while that's doing its thing, we're gonna go ahead, and I went ahead and installed Firefox, and I installed Chrome. while you were away, or while I was transferring that drive over. So, all right, so that gets us around the Internet Explorer bottleneck, firewall bottleneck, basically. So it gets us around that because we're going to go in here and we're going to download some utilities that I like to use. So we're going to load CrystalDiskInfo. It's getting late. I can't type. So we're going to download a couple of utilities here. All right. So we're going to load... What the... Oh, go away. That's new. Evidently CrystalDisk thinks because they make an awesome utility they have to start throwing pop-ups at us. That's great. It is a really good utility. And it's free. So... Alright, and so we're going to load CrystalDiskMark. That way you can benchmark our drives and see where we're at as far as speed. Okay, so we got those. Let's see, we need hardware info. So HWinfo 64. So because our motherboard didn't come with its own utility and the download, we're going to install hardware info. That way we can monitor all of our temperatures and everything from Windows. So, alright, so there's that. So we got that, and that, and we're good for the moment. Okay, and that's still installing. Okay, so we're going to go to our downloads. We're going to load our CrystalDiskInfo here. No, that's fine. Okay. So one nice thing I like about CrystalDiskInfo is it allows us to be able to monitor all of our drives. So right here, so this is disk 0 through 3. Those are our 2 terabyte Seagate Exos drives. So it gives us power on hours, power on count, how many times have been turned on and off, spin speed, but it gives us all of our temperature readings on the drives and everything else. So, and then we can click up. Of course, these are all the same. And then here's our Evo drives. So the one nice thing about this in particular is it tells us our host reads, our host writes, power on count, power on hours. Now on an SSD, your power on count and power on hours don't really mean anything, because you don't have any moving parts inside of the drive. So realistically, as long as it's not running too hot, so right now it's running 45 degrees C. That's about normal. SSDs can run all the way up to about 60, and they're perfectly fine. Anything really probably past 70 is going to be a problem. That means you probably don't have really good airflow inside your case if you're running that hot. So, but the big thing with SSDs is this host writes. So SSDs are guaranteed for so many terabytes of data written. And so that's what this guide keeps track of. So once this hits, I think on these drives it's 600, I think it's 600 terabytes of data written. Then we're going to be outside of our warranty from Samsung. Also, too, we're going to be, the drive is going to be closer to failure at that point. So at that point, that's why we're running 2 of these in a mirrored set. It's just so because of the fact that we want to be able to keep an eye on everything. So, all right. So, and you notice the host reads when I went to this drive, it changed. Okay, so this is our write drive, and you can tell this is our mirror drive because it's only read 6 gigabytes, but it's written almost a terabyte. Where this drive, it's written 126 gigs, but it's read the almost exact same number as this drive's written. And so your mirrored backup drive, in theory, will wear out faster than your other drive, just because of the fact that it's constantly backing up the data from the one drive to the other drive all the time. So, all right, so there's that guy. So we're going to load our CrystalDiskMark, and we're going to click this guy through at the same time. Now, I like to run this to get kind of a baseline of performance. All right. And we're just going to create a default account because we're going to change it all later anyways. Okay, it's going to finish setting up our account here. All right, so this is our C drive. So this is our OS, our data drive, and our, oh, that's our USB. Okay, so we can take our OS drive. So we can run just a quick speed test on it, just to see what we're getting at the moment. Now, the one thing about the read and the write on these is it's going to be double. It's going to be doubled because the way Windows utilizes the 2 drives, it will actually pull data off of both drives simultaneously, as long as they're synchronized. So, and it writes the same data to both drives. So these numbers, people are going to look at this. It's like, how can you're running Samsung Evo Pluses? You're not running the new 980 Pros. How are you getting numbers that big? And it's like, well, it's because we have 2 drives and it's reading off both drives simultaneously. So nothing crazy. Oh, that's right. That other cable isn't connected. Okay, now it's up. I totally forgot about that. All right, so we gotta hit our yes here. Okay, all right. So this is the main Windows 10 installation that we're gonna go through, and we're going to fully update. And we're going to take this one, fully update it, activate it, and the whole 9 yards, get all of our basic software on it. So then that way we can take and then load. We'll actually take this and we'll export it out and then we'll replicate it by re-importing it, re-importing the replicated version out or back in. So that way we only have to create one Hyper-V once, and then we can just replicate the same desktop terminal however many times we need to. So and yes, we need to do Edge. Okay, so these are our write speeds over here. So you can see our write speeds are about normal for this particular setup, which is still 10 times faster than if we were using a traditional drive. So, all right, so there's that. Okay. All right, so there we go. Okay, so from here, we'll go ahead and install our Firefox. Now, on every machine I do, even virtual machines, I always install all three browsers. So I install Edge, Firefox, and Chrome. Because one, everybody has their preference, but two, you should always have at least two browsers installed in case one quits working on you for whatever reason. Sometimes companies will do an update, and then the website that you were accessing that browser with quits functioning like it's supposed to. You know, it's a common issue, especially with websites that don't get updated as regularly all the time. And so, yeah, it becomes a bigger issue. So, all right, so there's that. All right, so, okay, so we're going to go ahead and we're going to, oh, there we go. We're going to pin that down there. Great. We're going to Google. And we're going to get Chrome. No. Try to keep our internet traffic down to a minimum. That, and sorry Google, you don't need to know everything. You think you do, but you don't. You can feed your super AI with somebody else's data. Alright, so there's that. Okay, so we're going to keep this open. I'm just going to scooch this over. I'm going to open another instance of CrystalMark. So this is kind of the nice thing about CrystalMark is you can have multiple instances open. So now we're going to do the same thing, but we're going to do it with our data drives. And so you'll be able to see that the speed difference between the two is quite large. Okay, and there's our Google. Sweet. Let's see, I forgot to pin that. Okay. Alright, so from here, we can go ahead and start getting our updates done. Which it's going to have plenty. Because we just installed it at 1909, if I remember right. And nope, we installed it in 2004. And we'll actually go ahead and no. We're going to go ahead and just leave it at 2004. We're not going to install the 20H2 update just yet. I don't want to get too far ahead of myself, especially with some of the applications that this client runs. So you can see already, so this the data set drives, which are on our RAID 5, and right now they're resynchronizing. They're at a whole 6%. Fortunately, we're not going to write anything to them for a while. I'm going to leave this machine up and running for the next day or two, so we can fully resynchronize. Because it does take quite a while for them to resynchronize. The SSDs down here took about an hour or two to resync, but these drives up here, because of their size, will take some time to synchronize. But once they synchronize, they do run really, really well. So, okay. But you can already see that the SSDs are running nearly 10 times faster than our RAID 5 set down here. So if you need just a lot of little data all the time that people are going to access all the time, but you're not trying to like run an operating system or something like that off those drives, mechanical still has its place. It's still far less expensive than SSD. Like the NVMe SSDs that we're running in this particular machine are about $200 a piece. The Exos drives, the 2 terabyte Exos drives that we're running for our RAID 5 we're running 4 of those, so we're about $500, maybe $600 for the set of 4, which is still cheaper than if you were to buy a single 6 terabyte SSD drive, and then replicate that. So that's kind of the one issue, is you would actually have to buy 2 6 terabyte SSD drives and then replicate those. And so, granted, they would be faster, but and more so on the bottom 2 numbers, on the random reads and writes. They're going to be faster in here, but in the large data files, they wouldn't necessarily be faster if we ran them in SATA, because we're really at about the max speed of the SATA data bus. So we really can't squeeze a whole lot more data through the SATA data bus than we already are. So, anyways, okay, so, and that's almost done. But this is the huge, everybody always says, why should you run SSD? Well, the big difference between SSD is not just in the top 4 sets of numbers, but it's in these bottom sets of numbers. So these are the random, basically your really, really small files that your drive constantly has to hop back and forth to fetch when it's doing things. And so this is where boot time is picked up, and to a large degree, because when your Windows machine boots, granted, it's just loading a single large set of files really fast. But when it actually loads to the desktop, or when it actually starts loading services, well, each service is a file in and of itself, and then you have to load the desktop with all your applications, which have prefetch and everything else built into them. And so Windows is trying to load all these files all at the same time from all these different directions, and has to prioritize all these files especially on a mechanical drive, because you can only pull one file at a time. You can't pull multiple files simultaneously. And so on a mechanical, that's why these numbers are so slow or so small, is just because of the fact that we're in the kilobytes per second down here, because we're less than a megabyte per second data transfer. Where up here, we're nearly 80 times faster. 80 times here, and here we're nearly 100 times faster on the right side. So it makes a huge performance difference. And that is the power of SSD. Because SSD, you're not waiting for a mechanical disk, for a head on a disk to move back and forth across that disk and find the files. It can, with SSD, it just directly accesses those files instantly, or near instantly. So, all right, SSD versus mechanical drive 101. So even with the power of RAID, which makes these drives way faster for large files, for small files, it doesn't help that much. So we're still limited by the physical mechanical hardware. So, all right, so that's cooking. All right, so then we're going to go ahead and we're going to load our hardware info, which this will be an interesting look, because one, we're going to see how hot or how cold our system is running, because right now we're utilizing, we've got 2 virtual machines running, plus we got the main machine running at the moment. So we are pulling 22 gigs of RAM, which has been already authorized or allocated. Oh, don't worry about that. So you can see all 16 of our cores are actually bouncing around in here, similar to what this is. This gives us a graph to show, but you can see that, okay, so this first 4 threads here is basically our host operating system. These 4 back here are, or at least these 2 right here, are our Windows XP virtual machine. And then these 8 down here are our server virtual machine. So, kind of interesting. All right, so we're going to close this for the moment, and we're going to open up our sensors. Okay. And we are going to go down to our temperatures, and we're going to look at our CPU temps. And we are still running at about, well under 40 degrees Celsius. So this is the die average. Now the reason why the die average is so much higher is this is the individual CCDs, and I'm not sure what the T die is measuring in this particular machine, but this is the CPU die average, so the total actual average. One of the hottest running parts of this particular processor is the I/O chip. That's kind of the heart of the processor to a certain extent. You have the CCDs, which do all the processing, but the I/O is coordinating everything with everything outside of the chip. So with the drives and the network controller and everything else, and the memory. So it does, and also because it's larger, it's physically a lot larger than the CCDs, it is going to run hotter. So that's why our average temp is far higher than our CCD temp. So, but this gives you our overall CPU, motherboard, And also, if we go down here, we can find... All right, so there's our drive temps. So that's one SATA. There's our two 200 gig drives, or two terabyte drives, and these are our SSD drives. So our SSD drives are running at 46 degrees. That's probably, and the first number is probably the controller temperature, and the second number is, or is that the other way around? No, so okay, so the first number is probably the memory temperature. The second number is probably the controller temperature, because the controller is, the memory controller on the SSD is coordinating the read and the write processes throughout all the memory chips on the drive. So, and usually it's the controller that runs the hottest. So, okay. And of course, hardware enfocuses a whole bunch of other stuff, but that we're not super worried about. So, but good way to be able to take care of our, be able to do a lot of things. The other cool thing with this is you can do logging with this, and it's a little easier to do logging on this than it is to do it on within the Windows subsystems. So, okay. All right, so that's still installing. Groovy. Okay. Well, that's pretty much it. So we're going to pause for a minute. We're going to get this guy fully updated, and then we'll edit and come back real quick, and we'll show you how to do the import and export part of Hyper-V. So, okay. Back in a second. Okay, and we're back. Okay, so you can see our Windows 10 Pro has been activated, and we're fully up to date. So at this point, we're going to go ahead and export this. So we're going to go ahead and we're going to shut this guy down. Okay, and it's offline. All right, so then we're going to click it, and we're going to export. And because we got more room over here, call Hyper-V back up, but that's okay. All right, so actually, and I want to do one more thing. Okay. Yeah. Okay, so initial setup. All right. So I was going to export that out. All right. So, and that takes its sweet little time. So, but it's going to take, and it's going to export all the settings and everything for this particular virtual machine out to the other system, and then we'll be good to go. So, and then also what we'll have to do is just over here where it says import virtual machine, we'll just hit that, and we'll import that back in with a new instance ID, and we'll be ready to go. And we'll have to do that 1, 2, 3, 4, 5. We have to have 5 running on this one. So, okay, well, that's it. So once this is done, we'll come back here in a little bit. Okay, so our XP Pro VM has finished exporting, so now we're going to go ahead and start importing our duplicates back in. So, all right, we're going to hit new. Oh, no. We're going to hit import and do not show. And import from, we're going to go data, Hyper-V backup, initial setup, XP Pro, virtual machines. Wait. Folder containing virtual, okay. Nope, I didn't do that right. All right. All right, hit next. And there's our machine. And we're gonna copy the virtual machine and create a new unique ID. So that creates a new system ID within the system, within the Hyper-V manager. So, okay, and then I like to go through and make these all the same, so all my files are stored in the same area. Makes it for easier management that way. Oh, and then where you want to store virtual hard disks, same location. Okay, these should all be the same. They don't have to be, but like I said, if you want to set it up default, you can. My preference is not to do it that way. As far as the Hyper-V manager in Windows, it doesn't care. You can set it up however you want. And it's copying. So it's going to go ahead and copy the data off of from our data drive set over to our SSDs so we can run our machines, and then it's going to we're going to do this for a grand total of 3 more times because we need 5 total machines. So we'll pause and we'll come right back. All right, and as you can see, we've got our 2 machines in here, our Jenny and Jeff VMs. I didn't go through and do the other 3 because I don't know what to name them just yet. But it doesn't take very long. It takes all about 5 minutes to do the import. So it doesn't take very long. But we can go in here. We can see that there's our desktops. They're up and running. And the beautiful part about this is when you do an import, we can go to activation and look at that. It's still activated. So you don't have to go through and reactivate every single machine that you import from the other unit. So basically doing an import-export like this is basically the same thing as doing a VM clone if you're used to VMware. Microsoft doesn't call it that, but essentially that's exactly what it is. So, all right, a couple things we need to do. We need to go in here and we need to, not that. We need to go in and we need to adjust settings on these. So then that way, in case the power goes out and we lose power, the machine shuts off, then the system will automatically just come right back online. So, and it will launch all the virtual machines automatically. So that's what this stops. Now, by default, each virtual machine, so if the host machine shuts down or restarts, it automatically goes into a save, where it automatically just saves all the virtual machines in place. And so that way when they come back up, they don't actually have to do a full reboot. They just kind of come out of a virtual hibernation, basically. So, which is actually really handy because especially on a system like this where our reboot times are less than, depending on what we're doing, but it's less than about 60 seconds. Makes it really nice because then your entire system is only down for just a brief moment versus being down for half an hour or whatever, and then it has to shut all the virtual machines down and then restart and then come back up, and then it has to launch all the virtual machines. At this point, it's almost instantaneous. As soon as the Hyper-V services start, it'll pretty much instantaneously restart those VMs. So, yeah, pretty impressive, honestly. Hyper-V has come a long ways since its very first iteration as Microsoft Windows virtual server. It's really come a long ways. So, I guess I will explain this real quick. So the startup delay. So the reason you would have a startup delay is, like, say for example, you had, again, you had 50 or 100 machines running on one Hyper-V server. You could start up delay, so that way all your you could prioritize the startup sequence from a full reboot so that way you're not totally bogging your machine down on startup, and it's bogging all the machines down, and they start one after the other. So that's what the startup delay is for. So that way all your virtual servers start first, and then all your virtual machines start after that. This particular instance, we've got enough horsepower, we can just start them all at the same time, and it's not going to do anything. The machine's just going to look at us like, ooh, you're going to make me work for a whole 5 seconds. Wow. That's impressive. Please try again. So, okay. All right, and that takes care of that. Well, there you go. That's Hyper-V 101, basically. So, if you have any questions or anything, leave comments below. Like, share, and subscribe. We will be doing... Well, this video will probably get split into 2 videos because of the length. But we're going to have one more video, and that's when this whole thing gets totally installed. And you'll get to see the installation part of it. And then we'll kind of do like a wrap-up review, I think, of kind of like lessons learned. So we'll go through the issues that we had with this particular system, and we'll go with things we had to change on the way. So, all right. Well, catch you next time, and bye for now.